Enough everyone, welcome to SimpliMath Batch 2026. This is our very first class and very first step towards your selection. And this class is all about Introduction to Elementary Maths. Now, why I am taking this class? Because there are certain students who fear math. It may be due to any certain reasons, but this math will establish a sort of framework, and this will help you see how I am taking care of each and everything from basic level to advanced through this whole journey of a SimpliMath batch. Okay, so basically in this class we will be covering introduction to elementary maths, where we'll be taking care of what is known as predecessors, successors, odd even numbers, introduction to the whole number system, prime composite number, proper, improper, mixed fractions and calculations, decimal calculations, factors and numerical calculation. Now, if you are someone who believes that you need know certain types of numbers and all, you are bit good in terms of basic, what you should do, you should pause this slide right now. You should try to answer all the questions. If you are able to answer it with 100% accuracy, I will put the answer in the class note. So if you are able to answer this whole thing with 100% accuracy, these 13 questions and these questions, then you do not need to watch the class, because all these things are in general covering in this class. Now, if you are unable to solve this, or if you are taking time, or if you are having hard time understanding all this, then watch this class. It won't cause harm, but it will give you a clarity. Okay, so let's start, guys. So the first thing that is known as predecessors and successors. Now understand, I will take it simply. Now what is predecessors? Pre means ahead. Let's say here is a number 5. Pre to 5, that means before 5. Pre means what? Pre means before. Okay, so predecessor is what? 4. Now successor means after. Successor means what? After. Okay, so what is successor of 5? 6. Now it might be possible you do not get a direct question here from mathematics, but these sort of questions are asked in reasoning, so this will help you to know what is a predecessors and what is a successor. Okay, you will get the handwritten class note in SimpliMath batch, in the paid batch, so do not need to write anything. Try to understand each and everything and give your full focus to this whole class. Okay, second thing, place value and phase value. Now see, when I write 1 is what? It is a unit digit number. So the place value of 1 is what? Unit digit. And its face value, what is the exact value of 1? 1. Now if I write 1 0, this is known as what? 10. And this is what? 2-digit number. What? 2-digit number. Now in this 2-digit number, the important part is 0 is known as unit digit. 1 is where? At the 10th place. 0 is at units place, 1 is at 10th place. So if I ask in 10, what is the place value? Place value of 1 is, as 1 is at 10th place, its place value is equal to 10. Now let's say if I write it as 25. Okay, in 25, 2 is at where? 2 is at 10th place. So what is the place value of 2? It is 20. What is the place value of 5? It is simply 5. Now if I say in 25, what is the face value? Face value of 2 is always that particular number. So this is how, if I give you a question, the question is like this, and number is 287643. Now in this number, what is the place value of 7 and face value of 8? Now what is the place value of 7? Now see, this is unit, this is 10th, 100, 1000, 1000. So what is the place value of 7? Now what you will do, you will put 0 over here only. You will directly write, sir, 7. After that, how many numbers? 1 2 3 4. 1 2 3 4. How much the place value? Sir, it is 70,000. If I ask place value of 2, you will put 0 for all these numbers and you will directly write it. So this is how you can write the place value. For face value, the face value is directly that same number. Clear? Sorted? Next. Even and odd number. I know most of you might have known it, but remember this. Even number is a number which is divisible by 2, which is divisible by 2. Okay, or you can say any number with unit digit 0, 2, 4, 6 and 8 is a even number. Clear? All other numbers are known as odd number. Now, how the questions will come, or what are the properties that are most important? Let's understand this. Now see, this is a brain teaser for you. So what will happen in this whole particular SimpliMath batch? I will teach you the concepts. I will help you solve the questions. So when I teach you one concept, you will get one brain teaser like this, where we will test whatever you have learned. We will be testing that. This question is known as brain teaser. Once that brain teaser is done, I will sum up this brain teaser, that is known as math mantra. Okay, with math mantra I will sum up all this brain teaser. Well, you will get the direct concepts in a simpler language. Okay, so this is the whole idea how I will be restructuring these classes. So understand each and everything. Now see, the first question is sum of 3 odd numbers is even, whether it is true or false. Now see, sir, you told us any number which is divisible by 2 is even number, or even numbers will have 0, 2, 4, 6, 8 in its unit digit. So sir, let's write 3 odd numbers, 3 plus 5 plus 7. These are odd numbers. Now if I add it, 3 plus 5, 8, 8 plus 7 is equal to 15. Now is it 15 an even number? No. So that means this is false. Clear? Sorted? Second. The sum of 2 odd numbers and 1 even number is even. Very simple. We'll try it. Sir, 2 odd numbers, let's write sir 3 plus 5. 1 even number, let's write sir 6. Sir, 3 plus 5, 8. 8 plus 6 is equal to 14. Sir, here in unit digit, 4 is even because 0, 2, 4, 6, 8 should be there in unit digit. That means this is an even number. So this is true, sir. Clear? So this is how you can verify it, or the math mantra says sum of any number of even numbers is even. Let's say you are adding 3, 4, 5, n number of even numbers. As many number of even numbers you will add, you will always get the sum as even number. That is the first principle. Now what will happen, and why I am teaching you this? May be possible there is a type of question known as data sufficiency. In data sufficiency, what happens? Questions will be like this. There will be 3 options, 1, 2, 3, and in the question it will ask whether option 1 and 2 are correct, whether option 2 and 3 are correct, whether option 1 and 3 are correct, or all the options are correct. And in these sort of questions, data sufficiency, you will be seeing direct conceptual based questions like this. So in order to tackle all these things, we are learning this. Clear? Now we've got the idea. First case, if you add any number of even numbers, you will get the even number. Case 2, sum of odd number of odd numbers. Like if I add 3 odd numbers, I will always get odd number. But in that case, if I add even number of odd numbers, like the last questions, here we are adding 2 odd numbers. Here 2 means what? Even numbers of odd numbers, and I'm getting what? Even number. So this is another case, that when we are adding odd number of odd numbers, we'll get the answer is odd. When we are adding even number of odd numbers, now this is the trickier part. Even number of odd numbers, that means what we are adding? Odd numbers. But how many odd numbers are there? That is in even format. That means I am adding, let's say 3 plus 5. These are odd numbers, but the total number of odd number is even, 1 and 2. If I add 7 over here, all are odd numbers, but the total number of odd numbers are odd. So here the answer will be odd, but in case of 3 plus 5, the answer will be even. So this is how the case 2 is given. In case 3, it is saying when odd and even number is added, when odd and even number is added, 3 plus 4, 3 is an odd number, 4 is an even number. What I will get? 7. This is an odd number. So whenever I will be adding odd numbers to even number, I will get what? Simply even number. No, I will get simply what? Odd number. But if there are even number of odd numbers plus one even number, I will always get what? Even number. Why? Because even number of odd numbers are getting me even number. Even number plus even number is equal to even. Now it might be possible right now you all are feeling this is a bit overwhelming because this is purely linguistic, and this is why I'm teaching you this from the very beginning, and this is what I'll be doing in the every chapter in the foundation class. Everything will be taken care of like this. I will bring you the language based models, I will bring you the language based questions, and will understand how to break down those things and how to understand each and everything. Now this confusing part, now you are getting that how sir is understanding where we are actually getting trapped, where actually we are not able to decode this particular thing, even number of odd numbers, even number of even numbers. So this is how I'm trying to help you learn the language. Clear? Sorted? The same way next two things are given. Now what will happen? Once you go through this class, you understand each and everything. Once it is done, I will be uploading this class note. Once the class note is uploaded, you will go through it. Then every day for this particular class, the assignment will be smaller one, but for regular classes the assignment will be a bit bigger, like 20-30 questions will be there. So in those classes what we'll be doing, whatever we have learned, we will be solving that in live Zoom sessions, and this feature is available only for paid students. Got it? So you will be solving that in the live session, the recording will be also available, and you will be understanding each and everything, clearing your doubts day on day basis. Clear? Now let's understand. Now see, for subtraction it is simple. If you take difference of two even numbers, you will get the even number. That means 4 minus 2. Let me change the color. Let's see. 4 minus 2 is equal to 2. 4 is even number. 2 is even number. The answer is also even. Here difference of two odd number is always even. 7 is an odd number. 3 is an odd number. 7 minus 3 is equal to 4. That is also a even number. Difference of one odd and one even number is always odd. 9 minus 4 is equal to 5. Now see, in a very simpler manner, we understand each and everything. Now we do not have to mug up everything. We can take out an example and we can understand each and everything. But before that, we need to understand that yes, there will be certain language like this, and we need to decode it like this so that we will be able to easily solve it. Clear? Now, for multiplication, product of all odd numbers are odd. Like 5 into 7, 35. Now how many odd numbers you will multiply? You will always get odd number. Product of all even numbers, if you multiply even number to even number, you will get even numbers. Now if you say, sir, if I multiply, sir, you told us that odd multiplied by odd is equal to odd. You said, sir, even multiply by even is equal to even. Sir, what happens when I multiply odd multiply by even, or even multiply by odd? I'll always get even. Clear? So this is how you need to understand everything. Now same for division. So when you are, let me change that. If the numerator is even and denominator is odd, numerator means, let's say here I am dividing 18 divisible by 3. So this can be also written as 18 by 3. In this part, 18 is known as numerator. Okay? And 3 is known as denominator. Clear? Now, when I divide it, when the numerator is even and denominator is odd, the answer will be even, because 18 by 3 or 18 3 is 6. Clear? And this is an even. Got it? Now, if both the numerator and denominator are even, then the result may be even or may be odd. Now see, here 18 is even, 6 is even. You get 3 as the number and which is odd. But if I say 12 by 6, now 12 is also even, 6 is also even, and the answer is 2. That is also even. So when you are dividing two numbers which are both even numbers, you may get an odd number, you may get an even number. Now this is the trickiest part. So if in question it is says, if I divide two even numbers, I will always get, understand this, you need to understand this language. If it says, if I divide two even numbers, I will, now understand this, always get even number. Is it true? No, because if I divide two even numbers, I will get even or odd numbers. It is not always. Now this statement is what? False. So this is where your data sufficiency question will be there, your statement assertion questions will be there, and you should not make silly mistakes. Now most of the students, they are good in math. It is not that they do not know these things, but because of the time pressure in examination, they do not focus over these sort of languages and they commit a silly mistakes, and because of that they are out of the race and they miss out the selection chance. So you need to be careful about all this. Now case 3, if the numerator is odd and denominator is even, then the numerator cannot be multiple of denominator, so this cannot be divisible. Let's say if I say 5 divided by 8, now 5 is what? Odd, 8 is what? Even. Now this cannot be completely divisible. Okay, this cannot be completely divisible. This will be known as 5 by 8, which is known as fraction. This is known as what? Fraction, and we'll learn about this in detail in this class in the later part. Clear? And fourth part, if the numerator is odd, denominator is odd, then the result will always be odd. Let's say 27 is odd, 3 is odd, 27 by 3 is equal to 9, it is an odd number. So this is how we got the idea about each and every properties of what? Each and every properties of even and odd, and this is known as what? Math mantra. This will help you get A's over other students. You will be able to find out the crucial part like this, where you won't make mistakes because you learn this from the very beginning, very first class, and when other students will be committing mistakes, you will be scoring 2 out of 2 in these questions. Clear? Now, this is a very important thing. Sum of two numbers is odd. If the sum of two numbers is odd, then the subtraction will be also odd. You take out any number in the world. Let's say I take out 15 plus 8. If I take out 17 plus 4, whatever I take out, when I am adding this, 15 plus 8 is equal to 23. This is an odd number. So 15 minus 8 is equal to what? 7. This is also an odd number. 17 plus 4 is equal to 21, odd number. 17 minus 4 is equal to 13, that is also an odd number. Now this is a very important part. These sort of questions are seen in various competitive examination, and you know adequacy is when creating questions. It is asking questions like this, and in also mains is all about conceptual clarity, right? Creating leverages for students. So these sort of things will put you ahead of a lot of students. So be prepared. Sum of two numbers is even if their subtraction will then their subtraction will also be even. Now see, when two numbers, if I add it, I get even number, I will get the, if I take out the difference, I will get the even number. So this is also in math mantra. With this, the very first part regarding predecessor successors, even number, odd number, place value, phase value, we are done. Now we'll move to the next part. What is that? Types of number, that is natural number. Now see, you always count numbers, right? 1, 2, 3, 4, 10, 20, 100, 200 out of 200, all these things. These are countable numbers and these are natural numbers. Only thing that you need to understand that 0 is not a natural number. So when it will ask about natural number, you will say it starts from 1 and goes on. Clear? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on. 0 is not a natural number. Now, 1 is a number. What is its successor? Successor means after 1. That is 2. Now 2 is what? Natural number. Clear? If I ask, is there any number which is a natural number and is it predecessor to 1? Now, what is the predecessor to 1? Sir, we know 0 is the predecessor to 1. Is 0 a natural number? No. So that's where you should not commit a mistake. What is the mistake you should not commit? That there is no predecessor to 1 which is a natural number. Clear? Simple. You will get it in handwritten notes. Do not need to worry. Just focus on the class. Next. What is a whole number? Natural numbers along with 0. So if I add 0 to all the natural numbers in the line, I'll get this whole thing as whole numbers. So in natural number, we are counting from 1. In whole numbers, we'll be counting from 0, 1, 2, 3, 4, 5. Now, if I ask, 3 is a number. Is it natural number or is it whole number or is it both natural and whole number? Now what will say? Sir, 3 is a natural number. That is correct. 3 is also a whole number. That means 3 is both natural and whole number. Now when I say this for 0, you can't say it for 0 because 0 is not a natural number, but 0 is a whole number. Okay? Clear? Sorted? Simple? Next. Brain teaser. As usual, whatever we'll learn, we'll test it directly. Are all natural numbers also whole numbers? Yes. Starting from 1 till how many numbers I can count, all are whole numbers. So answer to this question is yes. Are all whole numbers also natural numbers? Read it again. Are all whole numbers also natural numbers? You can't say yes because 0 is a whole number which is not natural number. So are all whole numbers natural number? Answer will be no. Now which is the greatest whole number? No one knows because you can't count. But if you ask what is the smallest, here if it asks what is the smallest whole number, the smallest whole number is equal to 0. Clear? Sorted? Enjoying it, right? Next. Next number is known as integers. Now, you might have seen certain numbers are written like this: -5, -10, -50, -100. And there are some numbers as 1, 2, 3, 5, 6. Now, all these numbers that are minus sign, plus sign and 0 are known as integers. In integers, there will be positive integer which carry positive signs and negative integers carry negative signs. Now, there are certain rules to it you need to understand. Now understand notes, okay? In positive, I'm writing positive like this. In positive integers, successors are always greater and predecessors are always smaller. Whatever the number will take, like here 0, 1, 2, 3, 4, 5, the successor of 2 is 3, so 3 is always greater than 2. Now I'll always write 3 is always greater than 2. Now, if I talk about predecessor of 2, that is 1, so I'll write 1 is always less than 2. This is greater than symbol. I hope you know it, but I'm just repeating for the sake of your understanding. This is lesser than symbol. Clear? Now, if I talk about this in case of negative integers, you need to understand that in negative integers, you can't say minus 5 is greater than minus 4. In negative integers, we will always see it this way. We will always count towards 0. That means the successor will be always towards 0. That means minus 3 is always less than minus 2. Minus 3 is always greater than minus 4. Here, minus sign means minus 3 will be greater than 4. Because of the minus sign, the symbol changes. That is what you need to understand. Clear? Sorted? Next. Additive identity. Now, additive identity is what? Additive identity is if you add a number Now, what is identity? Additive identity is, let's say 5 is a number. What should I add to 5? I'll get always 5. What should I add to 5 that I will always get 5? Identity means same number I will get. Whatever I should add to this number, whatever it is, I will get the same number. So that answer is 0. So additive identity is 0. So 0 is the additive identity. So whenever you will be adding 0 to any number, you will get the same number. Now, what is multiplicative identity? Now, multiplicative means multiplication. That means whatever I multiply with a number, I should get the same number. And that can be what? 1. So 1 is the multiplicative identity, 0 is the additive identity. Clear? Now, what is additive inverse? Additive inverse means if I add something to this number, I will get 0. I will get 0. Clear? Yes or no? Now, what should be added to 5 so that I will get 0? If I add the opposite of 5, that is minus 5, I'll get 0. So this is known as additive inverse. Any number, if you take x is a number, its additive inverse is equal to minus x. Clear? Now, what is multiplicative inverse? So let's say 6 is a number. If I multiply something to 6, I should get 1. Now, if x is a number, if I multiply 1 by x with it, x gone. So what is the answer? 1. So for 6, the multiplicative inverse is 1 by 6. So for if x is a number, then its multiplicative inverse is equal to 1 by x. Clear? Sorted? Simple? Next. Calculation of integers. Now, when we are adding minus 5 plus 4, now what will be the answer? Is it 1 or minus 1? Now, in order to solve all these things, let me write certain rules for all of you. Now, when you are adding and negative integer is smaller than positive integer, then it will be subtraction and sign of the result will be positive. That means, for an example, if I'm adding 6 plus minus 5, so it will be what? Subtraction, that is 6 minus 5, and the answer will be 6 minus 5 is equal to 1. What is the sign? Positive sign. Clear? Now the second rule says, when you are adding negative integer with positive integer and negative integer is greater, then subtraction happens and sign will be negative. That means here if I add example minus 5 plus 4, this will be simple subtraction. 5 minus 4 is equal to 1 and the sign will be minus 1. Clear? Simple. Now third, when you are adding two negative integers, the sum will carry negative sign. For an example, minus 5 plus minus 4 is equal to 5 plus 4, 9, minus sign, minus. Clear? Sorted? Got the idea? Now, in case of subtraction, now I will write it in shorthand. So when you will be, there is a positive number and you are taking difference of a negative number. So what will happen? Positive, negative, negative, positive. So this will be positive number plus this will be positive number. For an example here, 5 minus minus 4 can be written as 5 plus 4, that is equal to 9. Remember this. This is first rule. Second rule is, if you take out negative number minus negative number, it will be negative number plus positive number, direct positive number. Now when this negative number plus positive number will happen, how it will look like? Now if negative number is higher, the symbol will be, or the sign will be negative. If the positive number is greater, this second number is greater, the symbol will be positive. Now let's say, for an example, minus 5 minus 3. So this will be minus 5 plus 3, that is equal to 5 minus 3, 2, but 5 is greater, so it will be minus sign. But in this particular case, if I write minus 5 minus 7, it will be written as minus 5 plus 7. Now minus 5 plus 7 is equal to what? 5 minus 7, that is 2, but here the larger number is 7. What is its sign? Plus, so the sign will be plus 2. Clear? So this is how calculation of integer happens, and you need to remember it. Sorted? Now for multiplication. In case of multiplication, understand this. Negative number multiply by negative number will get us positive number. Positive number multiply by positive number will get us positive number. Negative number multiply by positive number will get us negative number. Positive number multiply by negative number will get us negative number. Clear? So if I multiply minus 5 multiply by minus 4 is equal to 20, or 5 multiply by 4 is equal to 20. Here if I write minus 5 into 4, I will write minus 20, or if I write 5 into minus 4 is equal to minus 20. This is the example. Clear? Sorted? Now if this is the case of division, Now in case of division, negative divisible by negative, it will get us positive. Positive divisible by positive, it will get us positive. Negative divisible by positive, it will get us negative. Positive divisible by a negative integer or negative number will get us negative. That means if I say minus 20 divisible by minus 5 is equal to 4. If I say 20 divisible by 5 is equal to 4. If I say minus 20 divisible by 5 is equal to minus 4. If I say 20 divisible by minus 5, answer will be minus 4. Clear? This is what you need to understand. This is how the calculation happens. So you should not make silly mistakes over it. Done? Next. That is fractions. Now, any number, if a number, if a number is written in the format A by B, where B is not equal to 0, B is not 0, then it is known as fraction. Now understand this. If I say 5, is it a fraction? Yes, you can write 5 is equal to 5 by 1. Now 1 is 1 equal to 0? No. So this can be represented as a fraction. Clear? Now what is a proper fraction? Proper fraction means, and see, in A by B, A is what? Numerator. B is what? Denominator. In proper fraction, numerator is less than denominator. In improper fraction, numerator is greater than denominator. That means here I can say 3 by 5. Here 3 is less than 5. But in improper fraction, it will be written as 5 by 3 because 5 is greater than 3. So this will be known as improper fraction. Now what is a mixed fraction? Now if a fraction is written like this, 5 1 by 2, this will be known as mixed fraction. And what is the formula to it? So we will multiply 2 into 5 plus 1 divided by 2. So mixed fraction can be converted into improper fraction because 2 into 5 is equal to 10 plus 1 is equal to 11 by 2, and this is known as improper fraction. How we did it? We'll multiply 2 into 5 and we add 1 over here. So let's say a mixed fraction is like this, x y by z. So when we'll be converting into improper fraction, we'll write it as z into x plus y divided by z. This will be make it what? Improper fraction. Clear? Sorted? So in any case, if an mixed fraction is given, how you will make it into improper fraction? You will make it into improper fraction like this. Now if I say what is the improper fraction of 7 11 by 13, you will do what? So 13 7s are 91 plus 11 by 13. 91 plus 11 is equal to 102 by 13. This is the improper fraction. Clear? Sorted? Yes or no? Yes. Now like fractions. If two fractions have same, remember, let me write it in bold, same denominator, this is like fraction. That means 2 by 3, 1 by 3, this is known as like fraction. Clear? If two fractions or more, two or more fractions have unequal denominators, that is known as unlike fraction. That means 2 by 5, 1 by 7, 6 by 8, like this. Clear? Now what is equivalent fraction. Now let's say if a fraction is like this, that is 2 by 5. Now if I multiply 2 on the numerator and 2 in the denominator, I'll get what? 4 by 10. Now this 4 by 10 is known as equivalent fraction of 2 by 5. So you can directly say multiple of every fraction is equivalent fraction of that given fraction. Clear? Sorted? Simple? Next. Now we got the idea about fractions. Okay. Now what we will be doing? We'll be seeing certain things. Okay. Now, what is the comparison of fractions? Now see, when I will write, comparison means what? Is it greater than or lesser than or equal? Now remember one thing, all equivalent fractions are equal. So if it is an equivalent fraction, it is equal. Now, second rule, remember, if denominator is same, the fraction with greater numerator is greater fraction. Now let's say fractions are like this: 1 by 5, 2 by 5, 3 by 5 and 4 by 5. Now in all these fractions 5 is equal, but which numerator is the highest? 4. So 4 by 5 is greater than everything. 4 by 5 is greater than 1 by 5, 2 by 5, 3 by 5. Now 3 by 5 is greater than 2 by 5 and 1 by 5. 2 by 5 is greater than 1 by 5. Clear? Now, if denominator is not equal, but numerators are equal, then this is then the fraction with smaller denominator. Understand, here it was greater numerator, here it is smaller denominator will be greater fraction. Now let's say a fraction is known as 7 by 2, 7 by 3, 7 by 4, 7 by 5, 7 by 6. Now see, here 7 is equal, that means numerator is equal, denominator 2 is small here, so 7 by 2 is larger than 7 by 3, 7 by 4, 7 by 5 and 7 by 6. Now if I have to understand it in a very logical format, how would I search? See, I have 7 chocolates, okay, or I have 7 books. If I divide these 7 books between two students, every student will get how many books? 3.5 books. Now if I divide that 7 books among 3 students, every student will get around 2.5 or less than 2.5 books. That means what? As denominator is increasing, the numbers that is being divided is getting decreasing. That is why smaller denominator with equal numerator will always give me the greater fraction. Clear? Now remember this much here. In the simplification classes, where we'll be seeing if all the fractions are unlike, there is nothing like in those fractions, how can we find out, or how can we make the comparison of which is greater and which is lesser, or whether they are equal or not. Right now it is an introduction. I do not want all of you to burden with all these tricks. Remember this much trick for time being. Clear? Next. Now It is calculation. Now say it says 1 by 2 plus 1 by 3. Now when such calculation will happen, first you will do what? LCM of the denominators. Whatever the LCM of denominators you find out, you will do what? You will write it like this: divided by LCM of denominators. Then here for this particular question, you will do what? LCM of denominators divided by denominator of first fraction. Whatever you will get will multiply with numerator of first fraction. Then for the second fraction, again LCM of denominators divided by denominator of second fraction. Whatever you will get, this is division, will multiply with numerator of second fraction. Now in this case 2 and 3, LCM is equal to 6. Now what I will do? 6 divided by 2 multiply by 1 plus 6 divided by 3 here multiply by 1. So how much I will get? 6 by 2 into 1 is equal to 2 3 is 6, 3 into 1 is equal to 3 plus 6 divided by 3, 6 3 is 2, so 2 into 1 is equal to 2 divided by 6. The answer is 3 plus 2, 5 by 6. Now if I say this in a different way, let's say one question is 3 by 5 plus 4 by 7. Now here 5 7, its LCM will be 35. Okay, how to calculate LCM? If you are unable to do so, I'll teach you. Okay, but right now understand how this whole function is happening. Now 5 7 LCM is 35. So what I will do? 35 divided by 5 multiply by 3 plus 35 divided by 7 multiply by 4. Now 35 divided by 5 is equal to 7. 5 7 is 35. 7 into 3 is equal to 21 plus 7 5 is 35. 5 into 4 is equal to 20 divided by 35, that is equal to 41 by 35. And this is what? This is an improper fraction. This is how you can do the calculation. Now this is what? This is for addition. For subtraction, the same thing will happen, only in case of plus sign you will put a minus sign. Clear? That will be happen in case of subtraction. Clear? So let me write the formula. If you are very weak in math, do not worry, as I am taking care of each and everything, you can understand it. LCM of denominator divided by denominator of first fraction multiply by numerator of first fraction plus or minus. If it is plus, if they are adding, you will put plus. If they are subtracting, you will put minus. LCM of denominators divided by denominator of second fraction multiply by numerator of second fraction, and so on. The many numbers of divided by LCM of denominators. So this will be used for addition and subtraction. Only symbol will change, everything else will remain same. Now if it is multiplication, let's say 1 is 2 by 7 multiply by 3 by 8. Now in this case you will multiply 2 into 3 multiply 7 into 8. So in case of multiplication, numerator will be multiplied with numerator, denominator will be multiplied with denominator. Now whenever we will be calculating this, we have to ensure that we are finding the equivalent fraction of it, or the smaller version, the smallest version of it. So before you do the calculation, you can cross out here. See, 2 4s are 8. Now this cannot be further calculated, so I will write 3 by 28. If I do not even calculate this, I can write 2 3s are 6, 7 8s are 56. I can write it this way, and if I divide the both numerator and denominator by 2, I'll get this much as well. So you will be doing the multiplication part this way. Now if I say what is the multiplication of 14 by 13 multiply by 7 by 8. First you will do what? You will try to cross out, sir. 2 4s are 8, 2 7s are 14. Now 7 7s are 49 divided by 13. You can find the answer like this. Or you should directly multiply 14 7s are 98 divided by 13 8s are 104. So this way you can also find it, or this way you can also find it. Clear? Sorted? In multiplication, numerator will be multiplied with the numerator, denominator will be multiplied with the denominator. Clear? Sorted? Next. Sorry, division is gone. In case of division, so this is multiplication. In case of division, what happens? Let's say 2 by 7 divided by here 3 by 8. So this will be written as 2 by 7 multiplied by 8 by 3. Remember this. So this will be 2 into 8 is equal to 16, 7 into 3 is equal to 21. So if I'm dividing A by B with P by Q, it will be always A by B into Q by P. Like if I write it like this, 2 by 7 divisible by 3 by 8, it will be written like this, 2 by 7 into 3, 8 will go on to the upper part. And if you'll solve it, you will get the same answer. Clear? Sorted? Now see, till here we are learning what is a natural number, what is a whole number, what is an integer, what are the fractions, and we got the each and every part. Face value, place value. Now what are the decimals? If a number is written like this, 15.5, 14.36, 12.184, 11.1987623, such way, these will be known as decimal number because this is the point over here. Now the most important part is you need to understand that here this is the unit digit, this is the 10th, this is 100, then 1000, then 10,000, then 1 lakh and so on. But in decimal it is the opposite. Opposite means this is 1 by 10th place. So this is 1 by 10th place, this is 1 by 100th place. The more, see, this is the decimal. So what is the tricks? If there is one number after decimal, you will put it as that number divided by 10. If there are two numbers xy, point xy, this is point x, you will write it as xy by 100. As many numbers are there after the decimal, that many zeros will be in the denominator. Clear? So in case of 12.184, it can be written as 12184 divided by 1. How many numbers are there after decimal? 1, 2, 3. So 30. Here in case of 11.1987623, this can be written as 11198763. How many numbers are after decimal? 1, 2, 3, 4, 5, 6, 7. So 1, 1, 2, 3, 4, 5, 6, 7. So this is how you can write down decimal numbers. Clear? Sorted? Now this is the basic of a decimal number. Now in your SSC examinations or railway examination, you see that is a thing that is known as recurring decimal. This is a basic decimal. Now what is a recurring decimal? Now recurring decimal is what? If it is written like this, 2.33333 and so on, or if it is written as 2.23, 23, 23, 23 and so on, that means 23 is getting repeated every time. Or if it is written as 2.3, 64, 64, 64 and so on, that means after 3, 64, 64, 64 is getting repeated. These are known as recurring decimal. Now how to do that calculation of recurring decimal? We'll learn it in simplification class. But why I am telling you this right now? I am just trying to introducing it to the decimal number so that when we'll be solving in simplification, it should not feel like this is unknown to you. That is the whole idea about this introduction class. Okay, so I'm trying to familiarize you with all these number systems. Clear? Now calculation of decimal. See, in terms of regular numbers, if I have to add 112 plus 80, how would I add it? 2 plus 8, unit digit to unit digit, 10, 0 here, 1 as the carry forward, 1 plus 1 2 plus 1 3, then 1 1 here. So this is how I am calculating. In decimal also the calculation will happen this way, but we'll write it like this. Understand, if I add 13.8 plus 14.76, so you will always put 0 over here if nothing is out there. Now what will happen? 0 plus 6 6, 8 plus 7 15, 1 carry out before that, decimal here, 4 plus 3 7 plus 1 8, 1 plus 1. If there is a number like this 13.543 to 12.78, what you will do, you will put a 0 over here. 3 plus 0 3, 4 plus 8 12, 2 out here, 1 out there, 7 plus 5 12 plus 1 13, 3 out here, 1 carry out, 3 plus 2 5 plus 1 6, 1 plus 1 2. This is how you will be adding it. Now if it is all about subtraction, in case of subtraction you will do it like this. Let's say it is written as 13.8 minus 12.16. So what I told you, first you will put 0. Now 10 minus 0, you will take 10. 10 minus 6 is equal to 4. This is 7. 7 minus 1 is equal to 6. 3 minus 2 is equal to 1. 1 1 0. So answer is 1.64. Now if it is written like this, 13.56 minus 12.78. So what we will do? 6 here, 1 6 16, 16 minus 8 8, 1 gone, so here 4, so you will take out 1 here, so 14 minus 7 7. Now here it is 12, 12 minus 12 is equal to 0, so the answer is 0.78. So this is how you will be doing the calculation of addition and subtraction in terms of decimals. Now you will say, sir, what about multiplication and division? So in case of multiplication and division, what you will do, you will first convert decimals into fractions and then multiply. Now let's say if I have to say 0.5 multiplied by 0.72. So what I will do, sir, 0.5 can be written as 5 by, how many numbers are there after decimal? 1. So 10 multiplied by 0.72. 72 divided by how many numbers are there after decimal? 1 2. So 100. Now 5 into 72 is equal to 360. Divided by 10 into 100 is equal to 1000. 0 0 gone. I can solve it further. 2 18s are 36. 250 is 100. Again I can solve it further. 2 9s are 18. 2 25s are 50. So the answer is 9 by 25. So this is how you can do the multiplication. In terms of division, you can do the same. Let's say if I say 0.42 divided by 0.14. So what I will do, 0.42 can be written as 42 by, how many numbers are there? 2. 100 divisible by 14 by 100. So this can be written as 42 by 100 multiplied by 100 by 14. 100 100 gone. 14 3s are 42. Answer 3. So this is how you can do the calculation in terms of decimal. See, this is basics. Here I am trying to introduce you to the whole number system. So do not panic. That's what I'm saying. Clear? Sorted? Now, what we know at the beginning, that natural numbers starting with 1, 2, 3 and so on. When we are adding 0 to that natural numbers, it become integers. Yes or no? Let me change the color. Integers. If I add 0 to the whole number, if I add 0 to the natural numbers, I get the whole number. Now, when we are adding negative part of the integers to the positive part, we are getting whole integers. And in whole integers, when we are adding fractions, decimals, recurring decimals, these are known as rational numbers. And this is called irrational number. Now, irrational numbers are what? Let me change the color. So, irrational numbers are the numbers which cannot be written as fraction. Simpler way, you remember it. The numbers which cannot be written in a fraction format, that is known as irrational number. Now complex number is what? So, and all these numbers, natural, whole number, integer, rational number, irrational number, as combinedly known as real number. So if I ask, is real number, all real numbers are natural number, you will say yes. Is all real numbers are whole numbers? Yes. Is all real numbers are integers? Yes. Is all real numbers are irrational numbers? Yes. That means you are failed. Why? See, root 2 is an irrational number. This cannot be a natural number. That is what you need to understand. But the opposite is true. All natural numbers are real numbers. All whole numbers are real numbers. All natural numbers are whole numbers. Not the opposite. Got it? All whole numbers are integers, but not all the integers are whole numbers. Because this set is smaller. This is part of this bigger set. Not the bigger set is part of the smaller set. Clear? Now, the complex number. Complex number is also known as imaginary numbers. The way you imagine certain things, the numbers are also imagined in terms of mathematics. And this symbol I is known as iota. What it is known as iota. And what is its value? Square root of minus 1. Square root of minus 1. So this is known as complex number, and when you add complex number with real numbers, this will get us what? The whole number system. Clear? Sorted? So with this we are introduced to the basic number systems. We understand what is what, and with this knowledge we can proceed further, learn each and everything, understand every part of number systems, and without facing any trap or any confusion in linguistic questions, we can answer each and everything without an issue. Clear? Sorted? So the very first class was very simple, very engaging, very important. Okay, now the last part of the first class. What is prime numbers and what is composite numbers? Now understand this. If a number has only two factors, one and itself, this is known as prime number. Now what is a factor? Factor means what? If I have to put it in a simpler language, factor means two number when two or more numbers are multiplied, you get the final number. Let's say if I say 15 is a number, so 15 can be written as, can be formed by 1 into 15 or 3 into 5. Yes or no? Yes. If I say 18 is a number, it can be formed 1 into 18 or 2 into 9 or 3 into 6. Yes or no? So this way you can say 1, 2, 3, 6, 9 and 18 are what? Factors of 18, because these are creating 18. These are creating 18. So factors are what? Creating 18. If I say what are the factors of your success? Factors of your success are being disciplined, being obsessed about the selection, completing the syllabus, attempting the all questions, attempting every class with full focus. These are the factors that will get you the success. So these are the reason behind getting this number. Factors are the reasons, you can say. So from factors you get the numbers. So if a number has only two factors, let's say 7, let's say 3, let's say 5, let's say 2. What are the factors? 1 into 7. There is no other regular number. If you multiply those two numbers, you will get 7. Or there is no two natural numbers. If you multiply it, you will get other than 1, 3, you will get 3. Or there is no natural number other than 1 and 5, which will get you 5. Same for 2. So prime numbers are what? The numbers which has only two factors, that are prime numbers. All numbers apart from prime numbers are known as composite numbers. Clear? All numbers apart from prime numbers is known as composite number. Clear? Sorted? Now, SSC mantra. What is SSC mantra? That 1 is neither a prime number nor a composite number. You need to remember it. And second thing, 2 is the only even number which is a prime number, and 2 is the smallest prime number. Apart from 2, all prime numbers are odd. Remember this. So this is most important for your exam point of view. Okay, even if in railway and in SSC you may see such theoretical questions in your examination. So this mantra, this math mantra is really important for your exam point of view. Clear? Now you need to understand that what are the prime numbers between 100. See, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. These 15 numbers are the prime numbers between 1 to 50. From 51 to 100, there are 10 numbers: 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So between 1 to 100, how many prime numbers are there? 25 prime numbers are there. Now you need to remember all these prime numbers, and you will remember this eventually. Why I'm telling you this? Because when you will be doing important calculations or tougher level of question, prime numbers will help you do a lot of things. So right now remember this. When you will be solving the question, you will understand why I was telling you this. So if I ask how many prime numbers are there between 1 to 50, you will say 15 prime numbers. How many prime numbers are there between 1 to 100? 25 prime numbers. How many prime numbers are there between 101 to 200? 21. 201 to 300? 16. 301 to 400? 16. You need to remember this much, not more than this. Clear? Sorted? Simple? Let's start with a brain teaser. All prime numbers are odd. Is it true or false? It is false, because sir, 2 is also a prime number and it is even. Clear? Now it is saying sum of two prime numbers is always even. Now see, always mean in every case. Now see, 2 is a prime number. If I add it with 3, will I get even number? No. But if I add 3 plus 5, I will get even number. So it is not always. Some cases where 2 is added, I will get odd number, otherwise I will get even number. So this statement is false. 2 is the only even prime number. True, because we know it from the math mantra. All even numbers are composite. See, all even numbers are composite numbers, all written. This is false, because 2 is the only even number which is a prime number. So remember this important parts. Remember this, how this particular one word makes a whole change, makes the whole definition of that particular question different. So remember this. Okay, clear? Now the last part, that is multiples of a number. Multiples of a number means what? If x is a number, you multiply any integer to it, you will get multiple of x. Let's say 2 is a number. Multiple of 2 will be 2 into 1, 2 into 2, 2 into 3, 2 into 4, 2 into 5, 2 into 6. Multiple means numbers getting from 2. Okay, so these are the multiples of 2. Now let's try a brain teaser. So let's match the following. 35 is multiple of 8? No. 35 is multiple of 7? Yes. 7 5s are 35. So these two are matching. Now 15 is multiple of 8? No. 15 is multiple of 7? No. 15 is factor of 30? Yes, because 15 2s are 30. So 15 is the factor of 30. Now 16, is 16 multiple of 8? Yes, 8 2s are 16. So these are matching. Sir, 20, is 20 Multiple of 8? No. Multiple of 7? No. Factor of 30? No. Factor of 50? No. Factor of 20? Yes, because 20 ones are 20. So 20 is the factor of 20. Now by default you will say 25 is the factor of 50 because 25 twos are 50. So this is what it is. So this is how you will understand what is a multiple, what is a factor, prime number, basics of composite number, and all other things about number system. Clear? Sorted? So that's all guys. With this we are done with the introduction to elementary math classes. I took it slow because there are certain number of students who feel underconfident. This means I do not judge them. I am right here to help you like this, taking care of your basics, taking care of your foundation, and make sure that you are scoring 50 out of 50 in math in tier 1 and 90 out of 90 in tier 2, 30 out of 30 in CBT 1, 35 out of 30 in CBT 2 of NTPC examination. This is my guarantee. This is the quality that I will be producing in SimpliMath batch. So get ready guys. All the best. See you in the next class.